Hello, my name is Liz Brandt. I'm the park naturalist at Berni Hanson Regional Park in Aldi. I'll be your trainer and judge for the wildlife section of the Envirothon competition this year. To give you a little information about me, I've always been passionate about wildlife and nature. I pursued my undergraduate degree in wildlife conservation and biology from the University of New Hampshire. Since then, I've worked in zoos, museums, and parks as an educator and animal caretaker. I also have my Virginia Master Naturalist credentials, and I'm also a certified park and recreation professional. So, our overarching training objectives are going to be for today introducing key concepts of wildlife ecology and management, identifying resources for further education and study, providing examples of ways to apply concepts, as well as broaden your awareness of critical skills in wildlife conservation. So we have some overarching umbrella categories that we're going to go into a little more detail about today, but these are generally going to be the foundation for the test questions. So you're going to want to know common species of Northern Virginia, both, or we're going to get into more detail about each of these, but definitely you're going to want to know the common species or at least the common families in Northern Virginia. You're going to want to know some general vocabulary regarding conservation, management, and ecology. You're going to need to know a lot of different ecology concepts, but don't worry, those are all covered in these study materials that are provided online. And then you're going to want to know some really basic, broad survey and management practices that we'll go over today. So in terms of common species, I'm not expecting anybody to become an encyclopedia. I will have field guides available at the test station, and any questions that you're asked will at least directly relate to the field guides, or any ecology sheets that I give you. But I would like you to generally know the common mammals, birds, reptiles, amphibians. Game fish, we're not necessarily going to address some of our common native fish, and then also invertebrate species, just down to the family. We don't need to be identifying every single species of dragonfly in Northern Virginia. I would like everybody to understand basic differentiating characteristics between these larger groups. So knowing how to tell a difference between a mammal, a bird, a reptile, an amphibian. Um, those are just some examples, but the reason that I want you to be able to do that, even though it sounds common sense, is that a lot of people get some of these categories mixed up. So one of the things that you're going to want to focus on is how you would classify these different groups of animals based on their physical characteristics as well as their basic biology. I'm again not expecting anybody to be an encyclopedia of all of the common species, but know the basics of, what makes a reptile and how that might impact their ecological place in our communities. I would also like everybody to have a general understanding of IUCN classification. Now, I don't need you to know what every single one of our common species is. If it's common, chances are it's a least concern species. But I'm not expecting everybody to know what each individual species is classified as. I would like everybody to know what the different classifications are. So understanding the difference between extinct versus endangered versus least concern as a few examples. Um, I'm going to be referencing back to the online resources that you're provided by the Soil and Water District, um, because the vast majority of the information that I would like you to know is in there. But I also want you to be able to apply critical thinking skills. So while you're reading through the Virginia Department of Wildlife Resources list of common species, I would like you to be thinking about how there are interdynamics between them and things like that. Field guides, understanding the basics of how to use a field guide. So animals that are found in field guides are usually classified into smaller subcategories. For example, if you're looking through a bird field guide, you want to know how to find the section that's just raptors or just ducks or just penguins. You want to be able to use a field guide effectively and know how to check range maps, because one of the main things that you would be doing if you're trying to identify a species in our area using a field guide is confirming that it occurs in our region. I'm not going to be asking you questions about species that don't occur locally. And then iNaturalist. If you're familiar with the app, I strongly recommend you just take a quick scope around at some of the species that are found in our area. If you're not familiar with the app, I strongly encourage you to make an account and check out some of the maps and the projects that have been done. You can actually check our park specifically where the competition is going to be taking place, and you can see what citizen scientists have recorded as species occurring within our park boundaries. So I do strongly recommend checking out iNaturalist. You're going to want to know general vocabulary. I'm not going to be able to give you a list, although all of the terminology is also in the individual study resources under the wildlife ecology subheading. So if you're looking over to the right where all the study resources are, if you go through at least skimming the wildlife ecology resources, you're going to see a lot of terminology that's going to stand out to you. And I want you to familiarize yourself with those definitions, but also familiarize yourself with the applications. So we're going to go over some of the larger terms and concepts in just a moment. But if you see something like the word parasite, familiarize yourself not only with what a parasite is, but also with how that could interplay into ecology practices and management practices. Okay, now we're getting into the nitty-gritty. So again, I'm going to give you all a very high elevation look at some of these ecology concepts. And then when we get into management practices, if anybody has questions about them, I'm happy to go into them. But I want you to understand the fundamentals. If you understand the fundamentals, then when you see the questions on the test, you're going to be able to apply what you know to real world situations. So one of the concepts I want you to understand is niche dynamics. So a niche is the role that an animal plays within its ecosystem. This does apply to plants, but because this is the wildlife category, I'm just going to be talking about animals today. And this is the way an animal interacts with the biotic and abiotic components within an environment, within their habitat. So it could be whether an animal moves around through the trees versus through the soil, could be what an animal eats, it could be what an animal prefers to drink. Just a few examples. I would also like you to understand the different ways in which species interact within their niche, but also avoid interaction or competition. So some of the ways that this might occur is temporal, so they might exist in different times. So for example, hawks versus owls, they actually fill the same niche, but one is predominantly diurnal, one is predominantly nocturnal. Structural. You've all probably already learned that forests have different layers. So do ponds. They have different layers. And so there may be two animals that fill the same niche, but are existing at two different layers of their environment. And so therefore they're reducing the competition that way. Now that is also covered in spatial, but spatial can also include a larger area as well as a larger geographic range. So you might have two species that occur or that exist in the same niche, but don't even occur at the same elevation, for example. And then morphological. An example of this, I hate to keep going back to owls, but they're easiest. You have large great horned owls, and then you have small saw-whet owls. They're both predators. They're both eating generally the same thing, but one is eating smaller prey, one is eating larger prey because of their body size. Okay, that ties well into food webs and predator-prey parasite relationships. So I'm going to go to the next slide for just a moment because I would like to address trophic levels and energy transfer. This is going to be the subject of a few different questions on the test. So familiarize yourself with diagrams like this. There are tons of examples online from a variety of different habitats. I just pulled a really generic one. But I would like everybody to understand the relationship between producers, which are 100% dependent on photosynthesis and are making their own food. They are not eating anything, versus consumers, which are the layers that are eating each other and the producers. And then you have the first layer of primary consumers, secondary, tertiary, quaternary. It can keep going depending on how complex the food web is. Now, keeping in mind, there is a lot more going on here than just a grasshopper eating grass and the sparrow eating the grasshopper. As you go up, you're actually reducing the amount of energy in each level. The main reason for that is because we all are expending energy every single day. So we sweat, we let off heat. If you use an infrared camera on pretty much any animal, you're going to see heat coming off of them. Roughly 10% of energy is transferred at each level. So that means 90% of the energy that's consumed by grass is not consumed by grasshoppers, for example, or any primary consumers. So only 10% transfer. Now that directly relates to the biomass, the sheer quantity of animal or plant material in each layer. So because only 10% of energy that is consumed by grass and other plants is then consumed by primary consumers, there can't be as many primary consumers because there's just not enough energy to sustain them, and so on and so forth. So understanding this concept is going to be pretty critical in understanding general ecology concepts, but this also ties very heavily into wildlife management practices because you have to understand whether a habitat can sustain a certain population size before you can start managing for that. I would like everybody to understand the accumulation of toxins. You hear most about this when you're talking about the ocean and heavy metals buildup. So there are two different types of accumulation toxins, or two different terms that I would like you to understand. The first term is bioaccumulation, and the second is biomagnification. Bioaccumulation is when you're talking about a single individual and the amount of toxin that they're taking into their own body. So it could be that they're getting it from their environment. It could be that they're getting it from food that they're consuming. It could be that they're getting it from water that they're consuming, or even in some cases, the air. So when we're talking about bioaccumulation, that's happening because the animal's body cannot get rid of whatever the toxin is. It could be a variety of different things. We'll use heavy metals in this case. So heavy metals tend to build up in muscle tissue. So if you have an animal that is consuming either a plant or an animal or water or inhaling air that has toxins in it and it can't get those out, then over time that is gradually accumulating. So that is bioaccumulation of the toxin. Biomagnification is when we're talking about the transference of that toxin through the food chain. So if you're talking about one, say, tuna, um, they are a predator. They are eating lots of smaller fish. Those smaller fish are taking in toxins from what they're eating and their environment. So the tuna, because it has to eat a lot of food in order to get its energy level met, it is taking in also a lot more of those toxins because it's taking in toxins from every single thing that it's eating. So that's biomagnification. And then there are three general symbiotic relationships to understand. So these are not predator prey. These are a situation in which one of the species, at least, is being benefited. So symbiotic just means that there's benefit for somebody involved, but it's not a food benefit necessarily, or it's not a predator prey relationship. So mutualism is when both species in a relationship benefit. You hear about this all the time with the clownfish and the sea anemone. That's a really, really classic example because one is being benefited by being fed and the other one is being benefited by being protected. Commensalism is when one species benefits, but the other has a very neutral effect. So it's not being benefited, but it's also not being harmed. And then parasitism is pretty self-explanatory. It is where one species is benefiting and the other is actually being physically harmed in some way. Another ecology umbrella concept that I want everybody to understand is resource availability. This ties in very, very heavily with management practices because you have to understand how a habitat is structured, but you also have to understand how an animal fits into its ecological environment in order to be able to plan management practices. So everybody needs to understand what a limiting resource is, and that is the one or possibly a few resources within an ecosystem that will cause a population to plateau. So in a hypothetical world, you've got, say, rabbits, and they eat grass. And rabbits, we all know that they can multiply like rabbits. So we end up with a population that's going up, 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 but there has to be a point at which there are too many rabbits to be sustained on the amount of grass that's in a space. Grass, it can grow, it can continue to grow, but at some point there are so many rabbits that they are going to consume more grass than can be sustainable. So that is a limiting resource. It's going to cause them to hit a ceiling. So limiting resources vary depending on the species. Some species, like for example, our wood frogs, they rely very heavily on a special kind of water source called vernal pools in order to lay their eggs. If we do not have enough vernal pools or we destroy a significant quantity of vernal pools, then that is going to very rapidly reduce the population. So the vernal pools are a limiting resource because if there are only a certain number of vernal pools, then there can only be a certain number of wood frogs. Also understanding specialists versus generalists. Our most prevalent example of a generalist around here is our raccoons, our beloved trash pandas. They will eat almost anything. They are generalists because they can adapt to almost any kind of habitat, including our backyards, but they're also capable of living in very remote wilderness areas. So they can be very versatile species versus a specialist, which needs very specific criteria within their habitat. And if they lose that, then they're out of there. Relatedly, we have keystone species, which are species that an entire ecosystem relies on. These are ones that people often refer to as causing a domino effect if we lose them. They're a singular species, be it a plant or an animal. We have more plant keystone species around here than animal keystone species, but still they do exist. So understanding how a keystone species loss can affect an ecosystem is going to be an important part of the test as well. And then this is going to tie in again with management practices, but knowing what an indicator species is. An indicator species is directly related to the health of the habitat. It's an animal that is sensitive to change. So an example again is our wood frog. They're an amphibian. Their skin is extremely permeable. They can become intoxicated by air pollution, water pollution, soil pollution, because they are so sensitive. They are literally drinking and breathing through their skin. So if an environment is unhealthy, if we deem it to be polluted, we can guess that, or we can be indicated on that by the presence or absence of these indicator species. So if an environment has absolutely zero amphibians, chances are there's some form of pollution that is driving them out if that habitat would have originally been acceptable for them. So we definitely want to focus on keystone species later when we talk about management practices. And now we'll get into management practices. So one of the things that you're going to need to know for the test, in order to start thinking about the way that an ecologist would approach different kinds of surveys, is being able to identify tracks and scat, skulls, as well as using context indicators. So I meant to have a diagram in here, but you have plenty of resources that have this diagram. When you're looking at tracks, there are a few different measurements that you would want to take in addition to comparing appearance. So if you have a tracks field guide, that is fantastic. It's going to be very helpful. I will have one at the test table, but it's just going to have a picture of the track. And if all you're doing is flipping through the pictures, there might be a little bit of confusion because a coyote track looks a lot like pretty much every other canid track. So it might look like a fox or it might look like a domestic dog. So one of the things that you're going to want to look at is measurements. And that's not just the dimensions of the track itself, say a coyote track or a deer track. You definitely want to measure across and lengthwise, but you also are going to want to measure the distance between individual tracks as well as the way in which they fall on the ground. So if you're out actually surveying for wildlife, finding one track is a great day. Finding an entire trail, or at least a segment of a trail, is where you're going to get your data from. So you definitely want to be able to do that. Same goes for scat. If you're looking at scat, you're going to want to take measurements. When you come for the test, I'm actually going to give everybody a specialty track ruler, and you can take that home. But you're going to be able to use that to measure tracks and scat. So in order to be able to identify those down to the species level. Skulls, they're a little bit more tricky, but thankfully we don't have a ton of overlap with skull identification here in Northern Virginia. I will not be testing you on a raccoon because raccoons are so commonly misidentified. However, when in doubt, it's probably a raccoon skull. If you see a wolf tattoo, if you see a fox tattoo, if you see a dog tattoo, it's probably a raccoon skull instead. But there will definitely be a skull on the test. Now, when I mentioned context indicators, I want everybody to understand what I mean by that. If you are out following a track trail, or you found scat in a certain area and you're looking through your field guide and you say, this is definitely otter scat. It looks just like otter scat. But you're in the middle of the woods and there are absolutely no water sources around. Chances are it's not otter scat. It might be a relative of an otter, but it's probably not otter scat because they don't typically stray very far from waterways. So looking at context clues, looking at where water is or what kind of habitat you're in, or even just looking at what is in the scat. Is there hair? Are there seeds? Is there whole fruits? Is there bones? Those are going to be great context indicators for what kind of animal that might have come from. Don't worry, I'm not gonna have real poop at the test table, I promise. All right. Another overarching category is general types of surveys. There are so many different kinds of surveys, and one of the resources that you have available to you in the online amalgamation of all the resources that are fantastic, I highly recommend at least perusing them, is the Animal Sampling Techniques document. That document is very detailed and extensive, and it's fantastic if you plan on going into a career in any kind of conservation. I highly recommend actually reading it through. You do not need to memorize it for this test. I want you to understand some general categories of surveys, and then when you're looking through that animal samplings techniques document, think about what categories those fall into, and then think about what tools you might use for the different types of sampling techniques. So first you want to understand the difference between direct and indirect. One is either laying your eyes or even your hands on the animal itself, and indirect would be doing surveys based on calls or doing surveys based on tracks and scat, or doing a survey based on general habitat health, for example. There are also surveys that measure biodiversity and population size. So biodiversity is when you're trying to get a feel for the overall population, or not the population, the overall number of species within a space. So if you've ever gone on a BioBlitz, that's what you're doing. You're going out and trying to catalog as many different species as possible. You're not gathering data about how many of each species there are. Now, if you're doing a population size survey, then you're going to be counting actual numbers of individuals. And oftentimes when you're doing that, you cannot be comprehensive. You can't go out and like cordon off a whole area and count every single individual in that space. Most of the wildlife species that we would be dealing with are either elusive or they're just really difficult to kind of corral into an area. So what instead you would be doing is taking a sample size and then extrapolating those numbers outward. So you might do a population sample within a certain quadrant, or you might do select sections out of a forest that are all randomized. And then you would be able to say, okay, well, I found 5 salamanders in this 5-foot by 5-foot space, and my forest or my habitat that is potentially habitable by these species is a mile. Then you do the math and figure out how many 5-foot by 5-foot spaces are in there, and then you can estimate population size within a margin of error. Another type of survey that might be conducted for management practices is a behavior or a health assessment. These are typically either using indirect or direct. A health assessment most of the time is direct because you want to actually get your eyes and potentially hands on a species in order to, or an individual, in order to be able to assess their health. For example, if you're doing a black bear survey, you're going to want to tranquilize the black bear. You're going to want to be able to do some weight measurements, some size measurements. You might be wanting to assess their body condition, as in how much fat is on their body, depending on the time of year. And that could also tie into behavior situations because, for example, if it's bears, you want to test whether they're in torpor for the winter. So you might be tracking them to figure out where they're hibernating. So those behavior and health assessments are really important for understanding what a population and what individuals are doing. We have a lot of diseases that are moving through populations here in Northern Virginia. You've probably heard of chronic wasting disease in deer. You've heard of white nose syndrome in bats. And more recently and more concerning, well, just as concerningly, would be avian influenza among both our raptors and our waterfowl. So definitely keeping those in mind and thinking you can even read current event articles about the ways in which behavior and health are being assessed in these populations. In order to adequately survey species, you have to understand their relationships with their ecology. You have to understand where you're likely to find them or unlikely to find them. You also have to understand what their predator, prey, or parasitic dynamic is. And you might do surveys related to those relationships. You might be trying to determine what, for example, owls are eating. So you might be out there in the woods collecting pellets that they have regurgitated and dissecting them to figure out what bones are left in those wonderful pellet gifts. You might also be doing a genetic survey. Genetics surveys almost always have to be direct, although you can get genetic material from scat, or hair samples. I have heard of surveys using barbed wire, deliberately using barbed wire to capture hair samples from animals like bear and deer. But most of the time, genetic sampling does require a blood sample. So that would be a direct, and you can find out a lot about population dynamics using genetic surveying techniques. one of the main things that you can find out is just how diverse the genetics are. In other words, figuring out through their history, have they always been a healthy population? Did they ever come down to a bottleneck and basically all the population now is interrelated? Are they destined for that based on how many individuals that they have? So those are just a few examples of questions that you can answer with a genetic survey. Um, Another management practice, information gathering component is a habitat assessment. So this is the counter to looking at the individuals or populations. This is looking at where they live. So you would need to understand key habitat features in the area, what kinds of trees, because certain species might be dependent on very specific species of trees or other plants. But you also want to look at how big the bodies of water are, what the salinity of the bodies of water are, whether they're moving water or still water, as just a few examples. But also, the habitats can be very diverse. You have different parts of a habitat. So, for example, between a forest and a field, you might have an edge habitat. There are certain species that need those edges. You also might have development in those areas, and we're going to talk about that in just a second. But that is still a key habitat feature because animals either are or are not adaptable to human encroachment. Population sustainability. So when we're looking at a population in relation to their habitat, do they have enough space? Do they have enough resources? Is there a limiting factor that the population is rapidly approaching unsustainable levels? Connectivity conservation is when we talk about the encroachment of people, but also the general movement of wildlife within an area. So if you have a large piece of contiguous habitat that is all healthy, then your population is going to behave the way that it has historically. And so it might be very predictable. However, if that space is then cut through by a major roadway, it's going to impact the populations of wildlife, possibly even down to the genetic level. There are some really great studies showing that even a major highway, if it separates two populations well enough, they can actually speciate. They can become two different species that can no longer successfully reproduce. But that can also happen with geographic separation, like mountain ranges, for example. But right here, we're definitely talking about interruption from human impact. So this could also mean that one large habitat is becoming pockets of habitat because of housing developments and stores and schools and roads, all sorts of different things that are kind of making our habitats more of a patchwork quilt than a large blanket of space. So definitely understanding those dynamics and understanding how wildlife is adapting to that. So there is a impact of fragmentation document in your resources. I highly recommend reading through that in order to understand how animals are adapting to fragmentation of habitats. Now, there's also habitat restoration and spatial planning. So, if you are seeing in your habitat assessment that there's room for improvement or that there's potential risk from future plans, say data centers in Loudoun County being introduced, every single one of those data centers before it's constructed has to do an environmental survey or pay to have one done. And so they are assessing that property for potential impact to wildlife. So they may be determining whether the space is viable or not, or they may be following our laws. And if they're destroying a habitat in one location, they have to then replace it in another location. So there's a dynamic between spatial planning and habitat restoration. Last but not least, let's circle back to those indicator species. So a habitat that was once sustainable for an animal that is sensitive may no longer be sustainable for that species. So if you're doing a habitat assessment, you're also surveying populations. Aquatic invertebrates are a great indicator species because some of them are more sensitive than others. So you can actually rank a habitat based on what indicator species you see in that space. Population management is what you do with the information that you've gotten from your surveys. So you are going to want to focus on population dynamics between predator and prey populations, but also how a population might be impacted by things that are happening in the area. If there's going to be a large deforestation, again, maybe because of a data center, we need to understand what the deer population is going to do with that information in order to develop management practices. Um, one of the things that you'll definitely want to be looking at are the different ways that species are managed, specifically here in Northern Virginia. One of the options that people often bring up is relocation. So that's not always an option because you have to be bringing the animal from somewhere or taking them out of a space and then finding a better place for them. So a lot of people bring this up when they are talking about human-animal conflict. For example, black bears getting into trash cans. That is not a viable option because if you are taking a black bear who is habituated to people and sees people as a potential source of very easy high calorie food, and then you're relocating them to an area that is much more remote, they are going to find people. Their noses are a thousand times better than ours, and they are going to find people and cause more problems. So relocation isn't always an option. Also, it can be very controversial. People often bring up with our deer populations being way too large around here, why can't you relocate deer out of the area, or why can't you relocate their natural predators back into the area? People would throw a temper tantrum if we reintroduced wolves into Northern Virginia. So those are things to consider because in some cases it is an option. Colorado just did a reintroduction of wolves into their wild spaces. And so far it's been very controversial, but very successful. So definitely looking into that as an option for population management is always on the table. But more often than not, we're turning to hunting and culling. Now, the difference here is hunting is typically more public. It's open to the public. They need certain permit. They have to follow certain regulations in order to harvest the animals. And more often than not, with hunting, it is for a food source. We here in our nature center have a black bear taxidermy, and we're asked all the time, oh, did somebody trophy hunt that? No, it was ethically hunted for a food source. Somebody did actually eat the meat of the bear. Again, controversial, but hunting can be an excellent management practice because not only is it getting the public actively involved in conservation and having a say in it, but it is also getting more people out in the field being able to do this practice than if you just had management professionals. Now, culling on the flip side is done almost exclusively by management professionals or people that those management professionals have hired. And that is just elimination of a certain quantity of the population or a certain demographic of the population of wildlife. So, for example, if there is a part of a population that is causing a human animal conflict. For example, there's a coyote that has just become too habituated and is stalking a neighborhood and taking people's pets. That animal might be culled for the safety of the public and also for the health of the general population. But more often than not, hunting, culling, relocating are all a direct result of human animal conflict. Because if we were not encroaching on these habitats, we would not be seeing these massive amounts of, for example, coyotes and foxes and black bears coming into our neighborhoods. But also because we have eliminated natural predators of deer, we have a deer overpopulation, and car accidents with deer are a human-animal conflict. So all of these different dynamics are a direct result of human-animal conflict. So it's always going to tie back in, and that's something that I'm going to ask about on the test. Now, last we've got invasive species in Northern Virginia. We have several different animal species and even more plant species, which I'm not going to touch on today. But familiarize yourself with some of the more common animal invasive species, things like spotted lanternfly, emerald ash borer. We've got lots of different insects. I'm trying to think of a non-insect. We've got snakeheads, which are a fish. Norway rats are an example of an invasive species. Starlings, house sparrows, just to name a few examples of invasive animal species. Um, Understanding how those came to be here and then how they're being managed, if they are being managed, because in some cases they are not. But in also a lot of cases, they are having a negative impact on our native populations. So understanding how that dynamic is happening will be pretty important on the test as well.
Thank you for viewing this virtual training for the Envirothon Wildlife section. If you have any questions, you are welcome to email me at elizabeth.brand@loudoun.gov or come during any of my office hours at the Hanson Park Nature Center, Monday to Friday, 10 a.m. to 4 p.m. You're also welcome to attend the in-person training where I can answer any questions and we'll also expand upon some of the survey practices as well as some of the other topics we covered today. I look forward to seeing you or hearing from you and seeing you at the competition. Good luck, everybody.